Alright students, we're here, and today's going to be similar to yesterday, but different. Instead of circumcenters, we're going to talk about incenters. And the end part of incenters is pretty important. And we're doing perpendicular bisectors yesterday, now we're doing angle bisectors. So very similar stuff, cool stuff, it all relates. It's pretty cool in all seriousness if you ask my opinion about it. Alright, anywho, let's get started. If a point is on the bisector of an angle, then the point is equal distance from the sides of the angle. This is called the angle bisector theorem. Alright, and here's a picture to illustrate what we mean. Alright, so we have angle A, B, C. So focusing on that angle, we can say, well, this is an angle bisector. Alright, this ray is bisecting the angle, and that's why we have these arcs here. Alright, cool. So just some typical angle bisector. Yeah, we've talked about that stuff. We're pretty comfortable with it. Well, D is on the angle bisector. So any point on the angle bisector is going to be equidistant to the side. So we can actually write, since ray BE bisects angle ABC, that means DF is congruent to DG. Alright, that's the angle bisector theorem. And the converse of this is also true. So why do we care about this? Why is this important? Well, it's a slow build up. We're just going to practice some problems to build our skills towards that. And then we're going to dive into some really cool stuff. So, and also the converse of this theorem is also true if you're wondering. So technically we could write it as a biconditional statement. So looking at this, is there enough information to determine if AB is on the angle bisector of angle CAD? Justify your answer. Well, yeah, it's equidistant to sides. So like, we got this point, we know this, and this is congruent. So we're saying, well, are these angle bisectors? Well, we actually don't know. The answer is no. We need to know. We'll be very specific actually. We need to know angle BDA. So like we need to know this angle and angle BCA. Alright, are they congruent? Are they perpendicular? Because if we look above, notice how right here above it says, well, that was perpendicular, and also that was perpendicular. Alright, we don't know if that's perpendicular down here, so no, not enough information. And then number two kind of emphasizes what I was just saying. Is point Y on the angle bisector of angle XYZ? And the answer is yes, because YX is congruent to YZ. Alright, they got equal lengths. We got this. This is guaranteed to go right through Y. And then this makes it the angle bisector because we got that and we know those are right angles. So enough information, yes. And since we're pumped up, we'll put a Nike swoosh. Alright. And then this one, just a typical algebra problem. So if you're missing some algebra right now, here's a great one to get your fix for the day. Alright, it's telling AB is the angle bisector. So since that's the angle bisector, these things are congruent. So when in doubt, just set things equal to each other. We get this cool equation right here. Don't forget to distribute first. Distribute 6x minus 8. Subtract x from both sides. Right, 7 equals 5x minus 8. Add 8 to both sides. 15 equals 5x. Divide by 5, and x equals 3. Sweet.